Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association. Welcome to Training Video Series 2, where we will explore the companion specifications. I hope you find these videos helpful. In this video, we will look at the STS202-5 companion specification. Please refer to the relevant document for detailed descriptions, and that document is STS202-5 Class 2 token extensions. This addendum to IEC 62055-41 specifies additions to Class 2 Subclass 10 tokens. Two pseudo-registers are introduced, a flag array having 512 single-bit flags and a control array having 63 10-bit values. Two token types are defined that allow control of these array elements. A third and fourth token are introduced as Class 1 Subclass 2 that allows displaying the content of flag array and control array, and these, of course, being Class 1, are not encrypted. Implementation of the tokens described in the specification are optional. If any of the tokens in 4.2 or 4.3 of STS202-5 are implemented, then the implementations of tokens in 5.1 and or 5.2 respectively is mandatory. So in other words, if you implement any of the tokens, you must then implement the tokens to be able to read what's in the arrays. Any of the tokens in 4.2 or 4.3, if any of those are implemented, then the implementation of the first token in each supported set, index 0 in table 3 and table 4, is mandatory, and that's for us to be able to do certain tests. Two parameters may be set: a flag, which is a 1 bit, 0 or 1, or a value, which is 10 bits in the range 0 to 1023. Let's look at the token field definitions. So the set flag token sets the value of a flag identified by flag index in flag array to the value specified in flag value. Okay, so it's a class 2 subclass 10. The index is 63. The flag index is 0 to 511, that's making a total of 512, and the flag value can be a 0 or a 1. Under the set control element token, it sets a value of an element identified by index in the control array to the value specified in control value. So again, it's a class 2 subclass 10 token. The index 6 bits, 0 to 62, making a total of 63. A control value from 0 to 1023 can go into any of these. The flag array, we can have a look at what that is. There's the first 11 indices. You can set flag for CTS test. That one must be implemented if you're implementing any of these. Detect tamper, disconnect service, disconnect the service delivery or enable service reconnection. Disconnect on tamper, disconnect on power limit. So there's quite a few, and I mean, I'm not going to read through all of them, but you can look at them. There's quite a few of these that are now defined and can be used in a payment meter if this set of tokens is implemented and this flag array and control array are implemented. In the control array, you can see that, for example, you can set a power limit duration, that's index 1, in 0.1 minute resolution or increments. And if you look at, for example, set electricity credit limit under index number 6, this sets the maximum electricity credit limit allowed in the payment meter, and in that case the resolution is 1000 kilowatt hours, because obviously the credit register is quite large, and so on. So this gives you the resolution of each of these registers and what you can in concept with them. Control array, again, there's a few more there. You can set water emergency credit limits, gas, time, overcurrent limits. So that's quite a large range of values that can be set in the meter using these control array settings. Okay, and there's just a few more. I've listed quite a few up to 30, which is the only ones that are defined, and then from 31 to 62, those are reserved by the STS Association, and they may in fact be defined later. All the token acceptance and rejection criteria apply as defined in 62055-41, unless otherwise stated in the document. If any of the tokens defined are not supported, the payment meter must reject the token as defined in 62055-41 for unsupported functions. So that would come back as a function error. Behavior of the payment meter after acceptance of the token is subject to the supply agreement between the payment meter manufacturer and the utility. So this is not specified how the meter will behave after receiving one of these tokens. The display flag, this token allows the user to see, to see the flags in the payment meter. It's a non-encrypted token. In other words, it's non-meter specific and it can be played to any meter. If it's not supported, it'll come back with a function error. If it is, then it will display the flags. So it's a class 1, subclass 2. The reserved 6 bits are set at 0 to 62. And then you also put in 9 bits of flag array index that'll tell you which flag you want to read. And res B set to 0, and then there's obviously a CRC at the end of it, like all the standard tokens. So assuming all the flags are set to 1 and the dash character indicating an unsupported flag, then the payment meter, if it supports flags 0, 1, 3, 4 and 11 with flags 2 and 5 to 10 unsupported, then the display will return 1 and then 6 dashes, an 11, a dash, and then an 11, or 1, 1 in other words. So that's the 1 means it's supported, the dash means it's unsupported, and they always come back with that same range of numbers. There is no other number other than a 1 or a dash character for unsupported. Display control element. This token allows the user to see a specific value in a control element. It's also a non-meter specific token, so it should be able to be decrypted by any meter. In fact, not decrypted because it's an unencrypted token. The display format is not specified, so it gives the manufacturer the ability to set and display many different meter parameters without the need for two-way communication channel to the payment meter. Look at the document. It's actually quite a powerful set of tokens, very useful. Of course, if you're using DLMS COSIM, this is probably not required, but however, they are there to be able to set different flags and different control values in the meter and read them back. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope to see you for the rest of the video series. Goodbye and see you again soon.